can see this. There are partitions here. Now what I'll do is I'll import an alignment. This is the alignment that we have. I'll open this. Nucleotide, that's what I tell you. All of you onto this. You can do it. You want to do it, you can do it, but please check once. Then click OK. You get this, that's what I told you. Then go into tip dates, use tip dates, you've got zeros, then auto configure, go to the last, say OK, you have got these values now. Now, what I tell you here is, see, the normal beast is run by selecting the model here, JC69. We are not running JModel test 2. It's a piece of cake, guys. I have a set of screenshots. Just run it. You can finish it up. We're not going to waste time on that. Now you have clock model here. Now in this clock model, let us say if at all you know that this is the optimum clock model, but you don't know what is the optimum clock model. What do? Go to strict. What is the strict? Okay, go to strict, then go to priorities here. What is the model that we have selected? We have selected coalescent constant population model, and this will take care of the population size. That's what I told you. Then you have MCMC here, the chain length that it runs for the bootstrapping, kind of a thing. It's not bootstrapping, guys. It's a kind of a thing. Is that okay? It's called as sampling trees. Then what do? You can save this file. Save as, right? What is this? This is a strict XML. Is that okay? Strict. I'll put it as sample because it may overwrite my work. Strict S. Right? You have saved that? Sony, is that clear till here? Sony?
Yes, sir. Yes, sir.
You have saved that file, right?
Yes, sir.
Next, what do? The same file again. You'll go into partitions. Tip dates are already there. Site model. Go to clock model. What do? You change the model and then save it as XML. You'll have 3 XMLs, right?
Yes, yes, sir.
You'll have to run all these 3 XMLs individually for your clock model estimation. Is that clear?
Yes, sir.
Now, one more thing. Someone asked me where to do the conversion of MCMC into NS. This is very, very important. Go to file. There are packages here. You see on the left-hand side of your screen. Is it left? Yeah. Left-hand side of your screen, you have manage packages. Go to manage packages, right? Invariably, you should have an NS package there. For me, it is already installed. If it is not installed, please install that software. This NS is there. Hi, Anna. Is that okay? Install that. And it will ask you whether to install or not. Is that okay? Once you're done, now go into launch apps. If it is installed, you'll have to go into launch apps. Launch the app. You have this package MCMC into NS converter. Hi, Anna. Right? And when you press this here, double click this. Sony, this is the place wherein you'll have to call these individual files for the MCMC that you have stored, and then you'll have to save it into MCMC NS files. For example, what have we called just now? We have called this file, right? This is the file that we have saved. Remember, strict as XML. Now you are converting that into a NS file. I'll just give it as strict S sample file, and now I'll just, for my this thing, I'll just convert it into NS, and I'll say OK. When I say OK, if I go into the download folder here, you will have, where is that package? Beast. Here. See, this is the file that I have saved and converted. Got this file?
Yes, sir.
Get it? What have you done? You have initially taken a model, strict model, saved an XML, taken that XML into the NS converter, saved it into a XML file again after converting it into a XML. Is that okay? Because the input for Beast is always an XML file.
You save the file in Excel.
First, you save the file in XML. The same file for conversion is taken into MCMC NS converter. And then to name it again, this is only to find out the best model. Is that okay? Right? Till here it's clear. You can't use this file finally. Guys, please have a look at this. You can't use this file finally for your Beast. This is only for the estimation of your models. This is only to estimate the best model, right? For example, if you estimated strict model to be your best model, the file that finally gets into Beast for your analysis of TMRCA is the strict XML file that is down below this file. Is that clear?
Yes, sir.
Right?
Where will be converted to MCMC?
I told you, that manage packages. Okay, I'll repeat that step again. Okay, guys, you have got tip dates, you have got site models, you have got clock model, you have got everything here, you have got priories here. In the clock model, first you're going to select the strict model and save that into an XML file. That's what I told you. Then after that, what happens? I told you, you have to go to manage packages and download a package in Beast that is called as NS converter. Is that clear? There is an NS somewhere. Here it is. Ajay, there is an NS here. Is that clear? And you have to install it if it is not installed. For me, it's showing that it is already installed. So I don't do it anymore. I go here, look at this, right? And then I go launch apps. I go to launch apps, convert this into MCMC into NS converter. Is that okay? This is the launch app.
So we have downloaded has a different interface. The
See,
options are different.
Did they download too?
Two have been sent. These two have been sent, right?
These two has been sent to you.
Yes. No,
Yes, sir.
These two has been sent to you guys.
two. I think which have.
क्या हुआ? You look worried. क्या हुआ? These two, है ना?
So the PPRD file which you send us, that is the faster file. You have to convert that file
Into an alignment file.
alignment file from mass
J model test.
J one. Then we put this into the video.
Then we'll put into BEAUti. Right?
That is
You can
the-
convert it using any other software. I gave you J model test 2 because I consider it to be one of the best models. Is that clear? Even in Mega, you can pull out that and save it in faster format.
When I put the alignment and select the alignment plus to W, it will not nothing selected for alignment, select all, and then it will initialize and then it will show something.
Hey,
So for the found in the translated sequence, please select the correct genetic code or the coding frame.
There's something wrong with your codons then.
Sir, I just copied that file of PPRD file.
We'll do that during the break. We'll finish off Beast and we'll do that. Right? Okay, guys. Now, let us say you have done all this exercise. Having done all this exercise, you have run the NS and you have got the marginal likelihoods and you have selected the strict model, guys. I'm not going back to this. Everything will be given. The only thing that I have not included in the screenshots is that packages part. And I don't have to include that probably because I have explained this. You know how to download the package and convert that into MCMC into NS, right? MCMC into NS. Okay. Now, once you get this, what did I tell you? If the strict model is considered to be your best model, you go and run your Beast. That's what I told you. So how do you run the beast? Now I'll just say no because I don't want it. I'll launch the beast application. For me, the beast is running since yesterday because I was trying to optimize something. Maybe I need to terminate that for your sake. Okay, guys. See, beast is running. Okay. I'll just stop this.
How long does it take to process?
That depends on your computer. I'm just closing that. Right. See, now what happens here? You choose your XML file here. All of you onto the board. You choose your XML file here, open it. Nothing else you'll have to do. This is the original XML file, not the converted file. Mind you again, it is not the converted file. The converted file you'll also run in Beast, but that is run only to select the best clock model, right? Now you run it. It will start running. See the running process, right? Let it run. I am quitting it, guys, because I don't want it to run. Done. I'll show you how the output looks like. The output here would look like this. You remember the other output with the NS? The other output with the NS XML will have a marginal likelihood, but this output will not have a marginal likelihood. That's what I told you. This output will just give you these calculations, whatever it is. Now, the most important thing that you'll have to understand here is, how will you find out all the parameters that you have considered are the best parameters for your analysis? All said and done, you have done your best to select the best model, best substitution model, best clock model, best priori. But how will you know whether you have selected the best model or not? Is that clear? Are you getting my point? All of you are here. If the offline participants are saying, which one, Beast? Okay. Guys, any doubts still here? Do you want me to repeat any part of that? Any part of this? Jasleen,
No, sir.
you have run Beast earlier?
No, sir. I have not.
Is this getting stuck? Okay, guys. Okay. Right. They again want me to explain the whole story once again. Quickly, in 5 minutes, I'll explain the whole story, right? So that it'll stay in your heads for a while, at least till the training gets completed. Right? Onto the board, guys. Don't have a look at as if like this guy is teaching something that is foreign to everyone sitting over here. Right? I want you guys to concentrate. And I have never taught these till date, just because I know that it includes so many modules and so many things to be explained. Is that clear? So that's the reason why probably in the evening when Usha told me that she cannot listen at all, I thought we should have your fresh brains in the morning. Even the fresh brain is creating a problem, right? Okay. Okay, we'll go into BT first. See, this is BT first. Go into BT, right? Import the alignment. Import the alignment. Where is the alignment? For me, the alignment is here. I pulled in the alignment. Say OK. Tip dates. Fine. Everything is given in your manual that we are giving it to you. No issues at all. Select before, after last. Right? And click OK. You get the dates. Site model. right? It's always a gamma because we assume that gamma distribution has a randomized distribution taken into consideration, JC69. Then the clock model. Here under the clock model, go for optimized, relaxed, strict model and random local clock model, right? For each of the models, using the same priorities and the MCMCs, save the XML. After saving the XML, get into the package by launching the apps here, convert the MCMC that you have stored into a NS. With that NS file, initially run your beast, get the marginal likelihoods, subtract the first marginal likelihood from the second one, right? For the model where you get a positive value, right? Consider that model to be a best model, looking at the table. Is that clear, guys? Right till here. Now you have selected a model, you have considered that strict model is the best model to be considered. Use the same XML that you have generated, which you have generated to convert the MCMC into NS, the same XML. Is that okay? Pull it into beast. Pull it into beast. Right? This is, did I close beast? Okay, this is beast here. Pull the, oh no, this is not beast. Yeah, here you choose the file. This is not the file to be chosen. It is not the strict NS to be chosen. This was chosen only for your model selection. And this will be chosen for your beast, final beast, because now you have come to know that strict model is the best model. You take that XML and put it into this. Open it and then run it. Is that okay? The moment it starts running, right? It will not run because there are certain overlapping files over there, right? We have already run that. The same name, and sometimes it creates a problem. We're done. Okay, na? Now, guys, what did I tell you? After running beast, I also explained that the output of beast that you have run with the NS file and the output of beast that you have run with the normal MCMC file, there are two different outputs. You will get marginal likelihood only in the output that you have generated after conversion of your MCMC into NS. Is that okay? And that marginal likelihood, here it is clearly mentioned that you need to convert, right? Where is that? Here is the marginal likelihood, remember? Right? Okay, done. All said and done. We have selected the model, we are running it, we have got the output. Now the problem is, you have got the output. Are you sure that the parameters that you have selected are the correct parameters or not? How do you test them? So what do? I told you, you have to go into tracer. Where is tracer for me? Where is tracer, guys? Okay, let me get into tracer. We'll get into tracer. Tracer opens here. Now it asks import a trace file. Now what did I do? You have got a log file from beast. This is the PPRV beast log file. I saved it as PPRV beast log file. You just open this here. Now what have you got over here? This is very, very important. And if you're not having a look at this file, then it means that everything is messed up. Guys, listen to me. There's only one parameter that you guys have to look into here. That is nothing but estimated sample size. You see this here? ESS. And this estimated sample size should always be greater than 200. Is that clear? If it is less than 100, this column, wherever it is less than 100, will be marked in red. And if it is between 100 to 200, it will be marked in yellow. Ideally, for analysis, it should be greater than 200. Now you ask me a question. Sir, you have considered all the best models, all the things possible, still you get a red. What should I do? You got the point? You have considered the best model to be there, that is the strict model. You have considered the best priori, right? You have considered everything. Now what should I do? Is that clear? You understand? The question here under consideration is the only thing that you can now change. You don't change the strict model, don't change the priori model. The only thing that you can now change is the MCMC chain length. Is that clear? MCMC chain length. Now we'll go and look at what MCMC chain length is. Okay. Beast. Beast disappear. Okay. See, in BEAUti, if you remember, we are looking at something very important. Even after selecting the best model possible, even then you are getting your ESS values lower than 200. The only way to correct it is once you call the alignment here, import alignment here. Once you call the alignment here, right? You remember you have selected all these models. Here there is a chain length, right? You remember? Now what we generally do is, these are all sampling trees. You should understand this is all sampling. We run beast. We run beast, right? With what? We run beast with one sample size. Is that clear? And we run again. You first have one XML. You have one XML and run a beast with one sample size. Is that clear? Right? And again, you select a second XML and run a, with this MCMC, you again run a beast. Is that clear? Right? Till here it's clear. You again save a third XML and run a beast, keeping all the other parameters constant. Is that clear? And then what you do, for all these logs that you get, and all the output that you get, what output do you get from beast? You get a tree and you get a dot tree and you get a dot log, right? Is that clear? Now what do? You have run 3 different XMLs, right, with the best models possible in beast. Now you remember I told you a module called as log combiner. Hi Anna, this module is there, right? You combine your tree files and the log files that you have run separately with all these XML files into a common XML, into a common tree and a log. Into a common tree and a log. Is that clear? And you will do this until this particular log, when pulled into tracer, gives you a ESS greater than 200. ESS greater than, you got it? I'm repeating this step once again. What are we discussing? You have selected the best model possible, you have selected the best clock model possible, and you have selected the MCMCs. Once you've got these MCMCs, you have run the beast, but you have got, what did you get? ESS less than 200. What do? Keep all the priori models, the site models and tip dates and all this are kept constant. The only thing that you would vary is chain length. For this chain length, select one. For second chain length, select second one. Do as many as you can till you get.
Excuse me, sir.
You get your ESS greater than 200. Yes, Jocelyn.
Sir, how do we, to what value do we change this chain length? Do we reduce a 0 or?
There is no standard. There is no, you cannot have a zero chain length, right? So there is no standard, but the minimum is the one that is already given as default. You can increase from then on. And the thumb rule is, Jasleen, you will have to do it until you get the ESS greater than 200. Got it?
Okay, sir.
So that depends on the user, whatever computing time and space you have, no issues, but you'll have to do it till you get the ESS greater than 200. Got it?
Okay, sir.
Right. Fine. So how do you do it? You generate the beast, you get these tree logs, you get 3 different trees and 3 different logs, combine all these 3 into a common tree and a common log, pull this common log into a tracer and find out whether you have got an ESS greater than.
So why are converted in log file, log file?
No. This is the output file. Beast
In log form.
या बीस्ट का 2 आउटपुट होते हैं, एक ट्री एक लॉग. वो लॉग फाइल हमको ट्रेसर में जाके देखना पड़ेगा कि वो ट्रेसर में ESS whether it is greater than 100 or
सर ये जो ग्राफ इसमें लॉग जो लॉग फाइल का डाटा है तो ये क्या रिप्रेजेंट.
मैं वही बोला अभी. There are lot of things that you can work out. For now, keep it in mind that this is the best thing that you can understand. Okay. Okay. There are a lot of things that you can ultimately do, but this is the basic thing that you do. Okay. See, this is the one where you pulled in, right? Isn't it? Right. See, actually what we didn't do is there is an estimate option given in the site model, right? Where you can tick and even estimate the mutation rate. Is that okay? See, I am giving you a sniff of what beast is and what are the intricacies that you'll have to look into. The rest of the things, there are hundreds of things that you can do. Is that okay? So first, the most important thing that you'll have to have a look at is the ESS. Okay, we'll just draw the tree. Madam is already here for her talk. We'll just draw the tree and we'll go, right? Then what did I tell you? Once you are satisfied that you have got the best value greater than 200, you have to go to tree annotator. You remember tree annotator? You go to tree annotator, pull in the, you have to select all this, pull in these files here. I have already pulled in the file, right? This is the tree file, right? That I got from Beast, right? I pulled in the file, then I saved it as the final file and I ran the file, right? For example, I saved it and I ran the file. This is how it runs. Is that clear? It simply runs and gives you the output. And what output did I get? I got a tree called as DNA.tree. That's what I saved, DNA.tree. I'll show you the output there because this is the file, DNA.tree. Got it? Now, this is the tree that you visualize. This is the tree that you visualize. How do you visualize a tree? There is a fig tree option here, right? I'm closing this. I'll call it again so that this is fig tree here. What do? You call in the tree here. Where is the open option? Open here, call in the DNA tree or final tree, whatever it is, right? DNA tree. Got it? Now, the most important thing and the struggle starts here. Where do you get the dates? You want to estimate the dates here. I want you guys to concentrate here. Finally, you have to get the dates onto the phylogenetic tree, right? Then only you can say that a particular branch has diverged at that particular point. So what do you do now? See that few things that I'll quickly, scale bar I'll remove at the bottom. What I'll do, I'll go to time scale. Is that okay? What was the earliest time that you said? 2015. Is that okay? And then here it is a -1.0. Right. Just take it as scale axis. You got the scale now at the bottom? You got it. Now what you have to do is reverse the axis here. I'll give you everything in that, right? 2015, it is 1, right? 1.0. And then you do it, right? You start getting the dates here, 2000, whatever it is. Is that okay? So the moment you get the dates, this is the final tree that you construct. I'm in a hurry, guys, because we are running late. So this is the tree that you get with the dates. You see the tree, and you can beautify your tree. You have the dates at the bottom, right? One is the posterior probability. Posterior probability is nothing but with what confidence you can say that this branch is always there. And how do you get it? It is the node label, right? For the node label, you go here, you can have what? You can also have your what? Years of divergence as node label, or you can go to this point and have posterior as your node label. You can play with it. I'll give you all the screenshots that are possible in the Beast PDF. Let's see what we can do. That's the end of the talk, right? Let's see how far you have understood. Thank you, guys. Take a 10 minutes break. We'll have tea and then we'll join back.